Now, heap sort contains two phases. One is constructing the maximum heap, and first phase is completed, constructing the maximum heap. This is the output of the maximum heap. Now, sorting operation. How we are performing sorting operation? By deleting the maximum element at the root node. So, this is the process we have to follow for performing the sorting operation. Okay, now here this is the maximum heap. So we are always deleting the maximum element from the maximum heap. So maximum element is always there at the root node. After deleting the maximum element at the root node, that can be replaced with the last element in that maximum heap. Last element in the maximum heap is 10. So now 18 can be replaced with the 10. So after replacing, 18 can be replaced with the 10, and 10 left child is 12, and 10 right child is 14, and 12 left child is 8, and 12 right child is 7, and 14 left child is 9. Okay, so this is the heap we are getting after replacing 18 with 10. Now applying the Heapify property. Okay, so Heapify property is always applied at the last node. Okay, here this is 9. Okay, 9 has no children, so hence it satisfies the maximum heap property. Next go for 7. So 7 is also a leaf node. It does not have any child, so that it satisfies the maximum heap property. Next we go for 8. So 8 is also a leaf node, hence it satisfies the maximum heap property. Next go for 14. Okay, 14 has only one left child, so 14 is greater than 9, so that it satisfies the maximum heap property. Next go for 12. So 12 has two children, 8 and 7. So 12 is greater than 8. It satisfies the maximum heap property. 12 is greater than 7. It satisfies the maximum heap property. Next go for 1, that is 10. So 10 is greater than 12. So it is false. It does not satisfy the maximum heap property, so that we have to swap these two elements. After swapping, so 12 is the root node, and 12 left child is 10, and 12 right child is 14, and 10 left child is 8, 10 right child is 7, and 14 left child is 9. Once again we have to check it satisfies the maximum heap property or not. So here 12 is greater than 10. Yes, it satisfies the maximum heap property. 12 is compared with 14. So 12 is greater than 14. It is false. It does not satisfy the maximum heap property. So that we have to swap these two elements. So then we are getting 14 as root node. Its left child is 10 and its right child is 12, and 10 left child is 8, 10 right child is 7, 12 left child is 9. So once again we have to check the maximum heap property or not. So first we have to start at 9. 9, 7, 8 are the leaf nodes. It does not have any childs. So single leaf node satisfies the maximum heap property. So single node is always a maximum node. So that 9 satisfies the maximum heap property, 7 satisfies the maximum heap property, 8 satisfies the maximum heap property. Next go for 12. 12 has only one child, so that is 9. 12 is always greater than 9. It satisfies the maximum heap property. Next 10. 10 has two children. One is 8, one is 7. 10 is greater than 8. 10 is greater than 7. Left and right child satisfies the maximum heap property. Next go for 14. 14 has two childs. One is 10 and another one is 12. 14 is greater than 10. It satisfies the maximum heap property. 14 is greater than 12. It satisfies the maximum heap property. So after that we are getting 1, 2, 3, 4, 5, 6, 7. Okay, here 14 is there, next 10, next 12, next 8, 7, 9. These are level by level we have to write. First 14 write, next 10, 12, next 8, 7, 9. Here only one node is deleted. The deleted node space is free. So at which we have to write 18. 18 is nothing but we have to delete that node. That deleted node can be stored in the free space for utilizing the free space. Okay. So next we have to, next in that heap, the maximum element is always at the root node. So the maximum element is 14. Now we have to delete 14 from that here. So now delete 14. Okay. So after deleting 14, 14 can be replaced with the last node. Last node in this tree is 9. Here 18 is already deleted. That is not considered only. So last node is 9. Okay. So 14 can be replaced with the 9. So now what is the tree we are getting? So 14 can be replaced with 9 because it is the last node in the maximum heap tree. So now its left child is 10 and its right child is 12 and 10 left child is 8 and 10 right child is 7. Okay, so this is the tree we are getting after deleting 14. Okay. So now apply the Heapify property. Heapify property after deleting 14. So then what is the array representation we are getting? So here 14 is already deleted. 9, 10, 12, 8, 7 and deleted elements are 14 and 18. So these are the deleted elements. So now 1, 2, 3, 4, 5. Okay. So what is the last element in this tree? So that is 7. Index 5, that is 7. So here we are starting the Heapify property from the last node 7. Here 7 is a leaf node. So it does not have any children. That means now single element is always a maximum element. It satisfies the maximum heap property. Next go for 8. 8 is also a leaf node. It satisfies the maximum heap property because it does not have any child. Next element is 12. Index 3, 12. 12 does not have any child. It is a leaf node. It satisfies the maximum heap property. Next go for index 2, that is a 10. 10 has two childs, that is left child is 8 and right child is 7. So that 10 is greater than 8. It satisfies the maximum heap property. 10 is greater than 7. It also satisfies the maximum heap property. Then go for after 10, then go for index 1, that is 9. 9 has two children, one is 10 and another one is 12. Okay, so 9 is greater than 10. It is false. It does not satisfy the maximum heap property. So that now we have to swap these two elements. So now we are getting 10. 10 is the root node and 9 is the left child and 12 is the right child. Next here 8 and here 7. Okay, so after array swapping can be done between 10 and 9. This is the heap we are getting. Okay, so now again we have to check whether it satisfies the maximum heap property or not. 10 has two childs. 10 is greater than 9. Yes, it satisfies the maximum heap property. 10 is greater than 12. It is false. It does not satisfy the maximum heap property. Now we have to swap these two elements. So now 12 is the root node and 9 is the left child and 10 is the right child, and 9 left child is 8 and 9 right child is 7. Okay, so this is the maximum heap we are getting after deleting 14. Okay, next we go for deleting 12. Now after deleting 14, so adjustments can be done. So 14 can be placed in this place because it is a free space. For utilizing the free space, the deleted elements can be right in this one. First 18 is deleted, next 14 is deleted. After 14 is deleted, this is the maximum heap we are getting. So now the maximum element is 12. It is located at the root node. Now we have to delete 12. Okay, so 12 can be replaced with the last node in the complete binary tree or maximum heap. The last node in the complete binary tree is index 5, that is 7. Okay, so now 12 can be replaced with 7. So 12 can be replaced with 7. 12 is replaced with 7. So after that we are getting 7 left child is 9, 7 right child is 10 and 9 left child is 8. Okay, so 12 can be replaced with the last element in the complete binary tree or our maximum heap, that is 7. After that we are getting, this is the tree. Now after replacing, now what is the last element in this tree? That is 8. Now Heapify property starts at this node. Okay, whatever the last node is there, Heapify property is always starts at this node. Okay, so now we are starting at this place, Heapify property. So 8 is a leaf node, so that means it does not have any children. Okay, so a single leaf node satisfies the maximum heap property. Okay, so that 8 is also a maximum value. Okay, after 8, next element is there, that is 10. 10 is also a leaf node, that means it does not have any children, so that a leaf node satisfies the maximum heap property. Okay, next node is 9. Okay, so 9 has only one left child, it does not have any right child. So 9 is compared with the 8, it is greater, it satisfies the maximum heap property. Okay, next go for 7. So 7 has two childs, 9 and 10. 7 is compared with 9, so it is false. 7 is greater than 9, it is false, it does not satisfy the maximum heap property, so that we have to swap these two elements. So then we are getting 9 is the root node and 7 is its left child and 10 is its right child and 7 left child is 8. Okay, so now again we have starting at this place. Okay, so last node is leaf node, that is 8. So 8 is a leaf node, it satisfies the maximum heap property. Next go for 10. 10 is also a leaf node, it satisfies the maximum heap property. And 7 has only one left child, that is 8. 7 is greater than 8, it does not satisfy the maximum heap property. Now swappings between these two elements can be done. So 9 is the root node, and here this is the 8, and this is a 10, and this is 8, left child is 7. Again we are starting at Heapify property at the last node, that is a 7. So 7 is a leaf node, it satisfies the maximum heap property. Then go for 10, next node is a 10. 10 is leaf node, it satisfies the maximum heap property. Then go for 8. 8 has only one left child, that is 7. It satisfies is greater than 7. It satisfies the maximum heap property. Next go for 9. So 9 has two childs, one is 8 and another one is 10. 9 is greater than 8. Yes, it satisfies the maximum heap property. 9 is greater than 10. So it is false, it does not satisfy the maximum heap property, so that swapping between these two nodes can be done. So after swapping, so 10 is the root node and 8 is its left child, and 9 is its right child, and 7 is 8 left child. So this is the tree we are getting. So after swapping, again we have to check the Heapify property from the last node. Here 7 is a leaf node, it satisfies the maximum heap property. Next node is 9. 9 is a leaf node, it satisfies the maximum heap property. Next 8. 8 has one left child. 8 is greater than 7, it satisfies the maximum heap property. Next node is a 10. 10 has one left child and another one is the right child. 10 is greater than 8 and 10 is greater than 9. Both are satisfying the maximum heap property. So after that we are getting, this is the maximum heap. So now, so after deleting 12, so this is the maximum heap we are getting. So here 10, 8, first level 10, second level 8 and 9, third level 7. And what are the deleted elements? So 1, 2, 3, 4. Okay. What are the deleted elements? So here first element is 18. So here next deleted element is 14. Next deleted element is 12. Okay. All after deleting 3 maximum elements. So this is the remaining array. So these are the elements that are already sorted. Now only 4 elements are there. Among the 4 elements, 10 is the maximum element. Okay. So now deleted the maximum element at the root node, because the maximum element is always there at the root node. So now we have to delete 10. So because 10 is the root node. Okay, we are always deleting the element at the root node in the maximum heap. So now after deleting 10, 10 can be replaced with the last element in the array. Last element in the array is index 4, that is 7. So now 10 can be replaced with the 7. So after that 10 is replaced with 7. Now 8 is its left child and 9 is its right child. Okay. So 10 is replaced with the last element in the maximum heap, that is 7. So 10 can be replaced with 7. After that we are getting, this is the complete binary tree. Now Heapify property is applied. Heapify property is always applied at the last node. So among the 3 elements, which is the last node? So 9 is the last node. Now we are starting the Heapify property at this place. 9 is leaf node. Okay, it does not have any child. A single element satisfies the maximum heap property. Next, go for next element is 8. 8 is also a leaf node. It satisfies the maximum heap property. Next element is 7. So 7 has one left child and another one is a right child. So that 7 is greater than 8. It does not satisfy the maximum heap property. Now we have to swap these two nodes. So after the swapping, we are getting, so 8 is the root node, 8 left child is 7 and the right child is 9. Okay. Again, we are checking the Heapify property from the last node. So here the last node is this one. Okay, 9 is a leaf node. It satisfies the maximum heap property because it does not have any child. Next, go for next element is 7. 7 is also a leaf node. It does not have any children. Okay, so it satisfies the maximum heap property. Next, go for 8. So 8 has two childs. One is left child and another one is right child. So 8 is greater than 7. Yes, it satisfies the maximum heap property. 8 is greater than 9. So it is false, so that swapping can be done. It does not satisfy the maximum heap property. So that swapping can be done. After swapping, so 9 is the root node. Its left child is 7 and the right child is 8. Okay. So after deleting 10, so this is the maximum heap we are getting. So now the array representation is so here first element is 9, first level. In the second level 7 and 8 are there. So what are the deleted elements? So the deleted elements are, first deleted element is 18. So 18, next 14, next 12, next 10. Okay, so after deleting 10, this is the maximum heap we are getting. Okay, next we have to delete the maximum element. The maximum element is always there at the root node. So now delete 9. Delete 9. After deleting 9, 9 can be replaced with the last element in that maximum heap. Last element in the maximum heap is 8. These are not the elements. These are already deleted elements. These are the existing elements. In the existing elements, what is the last element? So that is 8. So now 9 can be replaced with the 8. So now 9 can be replaced with the 8. After replacing, so this is the heap we are getting. This is the complete binary tree we are getting. Okay. So now after deleting 9, only 8, 7 are there. So here 9, 10, 12, 14 and 18 are there. After deleting 10, what are the existing elements? Only 8 and 7. So now Heapify property always starts at the last node. Here the last node is only two elements are there. First element is 8 and second element is 7. So the last element is 7. Okay. So now Heapify property starts at this node. Okay. So 7 is a leaf node. It does not have any child. So it satisfies the maximum heap property. Okay. Now next go for 8. So 8 is the next node is 8. 8 has only one left child. It does not have any right child. So 8 is greater than 7. Yes, it satisfies the maximum heap property. So after deleting 9, this is the maximum heap we are getting, and it also satisfies the maximum heap property by applying the Heapify property. Okay. Now next we have to delete 8. Okay. So after deleting 8, okay, this is the maximum element. Now delete the maximum element at the root node, that is 8. After deleting 8, only one element is there. So 8 can be replaced with the last element. 8 can be replaced with the last element is 7. So now 8 can be replaced with the 7. 8 can be replaced with 7. So now, this is the array representation after deleting 8. After deleting 8, only 7 is there, and the remaining elements are 8, 9, 10, 12, 14, 18. Okay, only one single element is there after deleting 8. Okay, so now Heapify property starts at this node. Okay, so because it is the last node and it is the root node and it is the first node, now Heapify property starts at this node. Okay, so now 7 is a leaf node. It does not have any child. Okay, a single node satisfies the maximum heap property because 7 is also a maximum value because it does not have any child. Okay, it satisfies the maximum heap property. Next, we have to delete 7. Delete 7, but 7 is replaced with it does not have any child. So deleted 7 only. So there is no replacement at the last node. So then what is the array representation we are getting finally? So that is after deleting 7, so we are getting 7, 8, 9, 10, 12, 14, 18. Okay, so this is the sorted array we are getting after deleting 7. Okay, now all the elements in the given elements are already sorted. Okay, all the elements that are given that are already sorted by using heap sort by applying the Heapify property. So this is the final sorted array. So in this way we have to apply the Heapify property for doing heap sort. First we have to construct the maximum heap using Heapify property. After that, deleting the maximum element at the root node. Again we are applying the Heapify property and also satisfying the maximum heap property. So this procedure is repeated until all the elements in the array or complete binary tree are sorted. Okay, this is the final sorted array. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Dibbela Srinivasarao. If you have any doubts, you can comment me or you can contact me. My WhatsApp number is also there. Okay, so thank you.